Number 5, the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r equals 1/20th 3 plus h squared, where h goes between 0 and 10. The units of r and h are in inches. Part A says to find the average value of the radius of the funnel. Well, we know average value is 1 over b minus a times the integral from a to b of the function. So in this one, it's going to be 1 over 10 minus 0 times the integral from 0 to 10 of the radius. So our radius is 1/20th 3 plus h squared dh. Okay, from here we don't get to use our calculator, unfortunately, so we get to work this out by hand. The one thing I'm going to do to start before I try to take the integral is, since 1/20th is a constant, I'm just going to bump it out front with the 1/10. So this will be actually 1/200th times the integral from 0 to 10 of 3 plus h squared. And then from here, since there's a plus sign, we can take the integral of each part separately. So I'm going to have 1/200th times 3h plus 1/3 h cubed. I get to evaluate that at 10 and 0. So if I plug in 10, I'm going to get 1/200th times 30 plus 1,000 thirds, and then minus 0. From here, this would actually be okay if you left it like this on the AP test. I'm actually going to get a common denominator just because I want to. So we're going to get 90 thirds plus 1,000 thirds. And then from here, this would be 1/200th. Well, actually, it would just reduce to 1,090 600ths, and then I could drop a 0. I'm going to get 109 over 60, and then the units were inches. All right, but again, if you just left it like that, you would have been okay. You would have gotten your points. This part was worth 3 points. If you have an integral set up, so you have this, that was worth 1 point. If you correctly found the antiderivative, so you have this part right here, that is worth a point. And then if you got the correct answer, you got your third point. So again, that part was worth 3 points. Okay, the part B says to find the volume of a tunnel. The volume of the tunnel, and the first thing that we know is they are circular cross sections. And I can notice if I look at these cross sections, because I see the circle right here, I can see that those cross sections are perpendicular to the h. So we want everything in terms of h, which everything is. So it's quite nice setup. So our volume is going to equal the integral from 0 to 10 of the area of our cross sections, which would be pi r squared, and our radius this time is the 1/20th, so this is going to equal 0 to 10 pi 1/20th times 3 plus h squared dh. All right, and once again we get to evaluate it by hand. One thing that I'm going to do, and actually I put that squared on the wrong part, it should be over that whole entire radius. To clean it up before I try to take the integral of it, I can separate, since 1/20th is multiplied by 3 plus h squared, I can actually square both parts. So this is going to be the integral from 0 to 10 of pi times 1/400th times 3 plus h squared. And now from here, I'm going to pull my pi over 400 out front because they are constants. And now I'll just be taking the integral of 3 plus h squared. So now I'm going to have to FOIL that. So when I do, I'm going to get pi over 400. That will simplify into 9 plus 6h squared plus h to the 4th. I'm not ready to evaluate yet because I have not taken the integral. So if I take the integral, I'm going to get pi over 400. This will be 9h plus 2h to the 3rd plus 1/5 h to the 5th. Now I get to evaluate it at 0 and 10. So I'll get pi over 400. If I plug in 10, I'll get 90 plus 2,000 plus 20,000. And then just adding those together, I'm going to get 22,090 over 400 pi. I can drop a 0, so I'm going to get 2,209 over 40, excuse me, over 40 pi, and it said to find the volume, and we're dealing with inches, so this will be inches cubed. So that would be my volume, 2,209 over 40 pi inches cubed. Okay, this part was, excuse me, also worth 3 points. We got 1 point for the correct integral setup. We got 1 point for, once again, correctly taking the antiderivative. So if you have this, you get a point. And then if you were able to get that right answer to end with, you also got a point. And once again, if you just wanted to keep your answer unsimplified, that would be 100% okay. So once again, 3 points. Okay, Part C. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3, the radius of the surface of the liquid is decreasing at a rate of 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So looks like we have a related rates problem, so I'm going to write down what they tell me. They told me that h is equal to 3. It says the radius of the liquid is decreasing at this rate, so this is going to be dr dt equals negative 1/5 because it's decreasing. And then it asked me for the rate of change of the height, so dh dt equals question mark. Right, so from here we need a formula that relates r and h, which would be this one right here. So we'll have r equals 1/20 3 plus h squared. And we would like to take the derivative of that. So the derivative of r would just be dr dt. The derivative of the right side, since 1/20 is a constant, it's just going to tag along. And then just take the derivative of the inside. The derivative of 3 is 0. The derivative of h squared will be 2h dh dt. And then we are solving for dh dt. We know dr dt is negative 1/5. And we get equals 1/20. 2 times my h is 3. And I do not know dh dt. So just continue to work this out. I'm going to get negative 1/5 equals 6/20, which would be 3/10 dh dt. To get dh dt, whoops, not hd, dh. To get dh dt by itself, I will multiply by the reciprocal, so times 10/3. And that should give me dh dt is equal to negative 2/3. And what per what? Looks like it's going to be inches per second. So this problem was worth 3 points. 2 points for getting the correct derivative. So if you ended up getting this, that was worth 2 points. And then you get 1 point for the proper answer at the end. So hopefully you did all right on this problem.